Alright, well, let's talk a little bit about lighting. Now, with this vessel, you have lighting that in the bow and in the stern, and not a whole lot in between except for maybe the diving bell bay and the sail. But one of the most prominent features of the Seaview is it has twin navigation position lights on the Cadillac fins. So, let's talk about that for a minute. So here is your Cadillac fin assembly. This has all been puttied up and worked on. And it's got a channel which goes from here to here. And I tested this, and if you put this on, there's no cutout in the hull to provide for when the fiber optic cable comes out of here. So I basically put some marks on here and got out my square file, and I put some notches in here. So I'm going to put this on kind of here, do a little dry fit, and here's some what I think it looks like 1mm fiber optic cable. So I'm going to go ahead and put this in here. So we're going to do a little test, and as long as this goes through clean, then that means I can glue these tail fins on and don't have to worry about threading this later. Okay, and it appears to go through clean, no problem, and you can see that it clearly did. So the idea is to, after this is constructed, to run that fiber optic cable through, and then I can run it all the way up through here as I need to. And the kit comes with not the actual Seaview kit, but the fiber optic kit I have comes with some 3mm LEDs and shrink wrap tubing. And then yeah, I can put the LEDs in here, the fiber optic in here, and shrink it around there, and then we'll be good with lighting up our tail fins. So there you go. One of the things that you worry about when you're lighting a model is light leaks, and the other thing is bleed through. So sometimes when you put LEDs behind plastic, the LEDs are so bright that they kind of blow through. So specifically with the Seaview here, there are some spotlights in the bow. There's one here, and there's one here, and there's one here. Now here with the model, this actually comes solid plastic, and you have to kind of file that out, which I've done. But in order to stop the light from kind of affecting around the plastic here, I've gotten some K&S brass tubing, and I've cut it. This is kind of cool. All you have to do is put it where you want it, and then carefully move this around until it cuts a small groove there, and then just kind of keep going. And then as the pressure decreases with the cut, you tighten it up a little bit, and you go some more, and eventually you'll get through it. It's not difficult, it just takes a few minutes. So I've got one of them done here, and that's that. So I'm going to do 3 of these. One's going to go here, one's going to go here, and one's going to go here. And I've already checked the clearance and everything. So the idea is that the LED will go in like so, and that way it's not going to light pollute the plastic on either side. So that's what we're doing. Okay, so one of the things we have to do here is what they call annealing the brass. And I don't know a whole lot about this. I've never tried to do it before, but from what I understand is photo etch brass is a bit springy, as it comes to you from the factory. And if you want it to bend around compound curves easy enough, you have to essentially heat treat it. So I'm going to take these limber hole photo etch brass pieces and put them on this burner right here and get them nice and hot. I think you have to get them red hot. Alright, so here they are sitting there. Okay, and it's 12:54 local here, and let's see how long this takes. Okay, so I got the lights turned out just so if we can, that way we can see some glow should it happen. I can see some discoloration on the metal now, so at least, you know, hopefully that's a step in the right direction. Okay, I'm not sure how much of this you can see, but from the naked eye here, these center sections, especially the second one from the right, starting to lighten up. So that means we're heading in the right direction. Still, on the ends are darker, but this is metal. It'll conduct this energy pretty good. So hopefully we'll get them all nice and bright here pretty soon. So you can see they're starting to glow a little bit, but you can't really see it when the burner kicks back on. But when the burner kicks off, you can see that the brass is starting to glow just a tiny bit. Okay, you might be able to see it now. But as soon as the burner kicks back on, it'll overwhelm. So they've been on there about, let me see, close to 15 minutes. I'm going to let them keep rolling here for a little bit. See if they'll, you know, glow a little bit more. So this has been on here for a half hour, and I think that's about as hot as it's going to get, because this burner will get to a certain temperature and turn off, and I don't think it's hot enough to make this actually glow red. So we're going to go ahead and secure the burner, let this cool down, and hopefully that'll be enough. Alright, so this is cooled down for better or for worse, and I don't know what all this residue is. It appears as though almost like there was a brass coating over stainless steel. I just don't know. But I'll try to wash all this off and attach it to the hull of the sub and see how it goes. I put these on a burner on high for about a half hour, and I never saw them get red hot, but they did start to discolor. And when I removed them from the heat and let them cool down, you could see, you know, how the finish here has discolored and gotten rough. Now I don't know whether that's an anti-corrosive coating or clear coat or whatever, but clearly it caused some damage. So I'm gonna have to sand these a little bit to get them smoothed up. In fact, one of them I already have. Like, it's pretty smooth, but it's still discolored. And I'm gonna put them on each of these little spots. And I'm just going to use a 5-minute epoxy and get them glued on there, and then I'm going to have to putty it in all around and get it looking smooth. Alright. Brass is on, and now what we have to do is putty all around it and blend it in.